All right, guys, we're going to be solving some more trig equations. So we might see some new or different techniques here when we are solving some of these problems. But let's start with a simple example to start. So we want to solve this equation for x, both on the interval from 0 to 2 pi, and also to just find the general solution. So what I'd like you to do is put me on pause. I want you to try this, and then we will check our answers. Okay? Go ahead and put me on pause. Okay, so first I started by trying to isolate this 3x. I got to this point, so I have 3x equals, and if I look for where the inverse cosine is negative root 3 over 2, I would find that at 5 pi 6, and then also 7 pi 6. But also, right away, I just added 2 pi n, right, to get all of my general solutions. So now I have 3x equals 5 pi 6 plus 2 pi n, and 3x equals 7 pi 6 plus 2 pi n. So if I divide both sides by 3, right, I won't usually show this, but if I'm, multiplying both sides by 1/3 or dividing both sides by 3, I got to do that to everything. So it might be helpful to look at these. So I get 5 pi 18th plus 2/3 pi n, and then also for this one here, I get 7 pi 18th plus 2/3 pi n. So those are my two general solutions, which I think is easier to find first. But then if I want my solutions just between 0 and 2 pi, well, because these are, in terms of pi 18ths, I figured out, 2 pi is 36 pi 18ths. So I want to figure out all of my possible answers between 0 and 36 pi 18ths. So I just keep adding these intervals here. So I have 5 pi 18ths, 7 pi 18ths, 17 pi 18ths, 19 pi 18ths, 29 pi 18ths, and then 31 pi 18ths. Okay, so it is a good question down here, and I'd like you guys to think about this. It says, if we were to graph this equation, how does the cosine of 3x change the graph compared to just cosine of x? Explain how this relates to the solving process. Now, you guys should be able to imagine this graphically, right? Again, it says, explain how this relates to the solving process. So go ahead. I'd like you to think about this. Put me on pause. And then let's move on to the next example. Okay, next example here. So we want to solve once again. We're going to solve between 0 and 2 pi and also find the general solutions. Now, just something to keep in mind for this one, a lot of times when people see this, they immediately want to divide both sides by cosine of 2x. But if you ever have to divide by something that has a variable and then it's going to cancel, you're going to need to do something else, okay? We can't lose that variable. That's a no-no. So let's see what you guys come up with. Go ahead, put me on pause. Okay, so I gave you a hint and said not to divide by cosine of 2x. So if I bring that over to the left-hand side and set equal to 0, now I can factor out a GCF of cosine of 2x. So using the zero product property, I'm going to set each of these equal to 0. Now, notice here, when I solve for and isolate the 2x, I get 2x equals all these things that are between 0 and 2 pi. So then my last step is then dividing each term by 2. For cosine of x, over here equaling negative 1/2, well, I have two options here. I have 2 pi thirds and 4 pi thirds. This was just x itself, so nothing else to do. To get my general solutions, however, so each of these go in increments of pi. So I had to set 2x equals pi halves plus pi n, but then dividing each by 2, I get pi halves plus pi halves n. And then for these two, I just want their coterminal angles, so plus 2 pi n for each. Next example. All right, let's have you guys try this one. It'll be really similar to the previous one. Go ahead, put me on pause. Okay, really similar to the last one, so I'm going to isolate the x over 3. So I get x over 3 equals inverse tangent of 1, which is pi fourths. So then I have to multiply both sides by 3, so I get x equals 3 pi fourths, which is my only solution between 0 and 2 pi. From there, I also want to find its general solution, so I know I'd have pi fourths plus pi n, but then I got to multiply each term by 3. So I get 3 pi fourths plus 3 pi n. All right, last example for this set of notes. My hint here is to factor. Okay, I do have this quadratic here. Not really quadratic, it's just a square term. If you're not sure how you would factor this, maybe try using some use substitution. Okay, go ahead, put me on pause. All right, guys, so you can see my work here and how I factored this. Now, like I was trying to give a hint before, if you were struggling to factor this in this way, you could have thought of this. Oops, that's a square. Sorry. You could have thought of this as like x squared. What happened to my pen? X squared minus 3x minus 10 equals 0, right? That I gave you guys that hint. You could think of it as use substitution. So now when I set these equal to 0, I'm going to get x equals arctangent of 5, which I want to think about where this would be. This is a positive angle in quadrant 1. So I also know that, I would get that it would also be positive in quadrant 3. So if I add pi to this angle, I could also get a positive 5 as well. So both of these answers will work here. Over here, so I'm solving, I get arctangent of -2, but this is a negative angle. So if I want to make this positive, because remember I want it between 0 and 2 pi, if I add pi, that's going to put this in quadrant 2. And if I want the angle that's in quadrant 4, I'm just going to take that original angle and just find its coterminal angle. Last but not least, our general solutions. I'm going to take arctangent of 5 and add pi n, just like we did here. We could keep going on and on and on. And then same thing with the arctangent of -2. I could add pi onward and get my general solutions. All right, so just as a conclusion here, make sure we set the equation equal to 0. Don't divide by variables ever. Factor if it's possible. If it is possible to convert all to one trig function, that would be great. And then here, if the angle has a coefficient other than 1, then solve for the angle and then solve for the variable by dividing by the coefficient. All right, thanks, guys.